This is the United States Energy Association Power Sector Podcast. I'm Herman K. Trabish, covered the power sector since 2006, and I currently report for Utility Dive. In this episode of the USEA podcast, we're going to talk about the disruption in supply of power sector transformers, an essential piece of electric transmission and distribution system infrastructure. Peter Ferrell, Director of Government Relations for the National Electrical Manufacturers Association, or NEMA, is going to describe the urgent need to increase transformer production to protect reliability and resilience as new resources, spiking electricity demand, and extreme weather events add unprecedented stress to the U.S. power sector. Peter's done government and policy work with NEMA for over 3 years. He began his career as a U.S. House of Representative legislative correspondent in D.C. and also spent 13 plus years in policy and industry affairs for the National Propane Gas Association. So, Peter, we're going to talk about transformers today. How would you describe the current status of transformer supply to the electric power sector? Maybe a few words even about what a transformer is and does.
Herman, thank you for the opportunity to join you today. So a transformer is something that most people probably see, but maybe not necessarily something they think about all too often. So a transformer in most day-to-day lives is called a distribution transformer, and that's the cylinder bucket that kind of hangs from a utility pole in your local neighborhood. And the technical reason for these transformers that are everywhere is that they step down power from the distribution grid, from distribution poles and utility lines, so that the power can go into your house or place of business and be acceptable at an acceptable voltage for the equipment within that business or that place to work, to function properly. And so, so these items are found in virtually everywhere you go, where that's to anything that's connected to the grid, and they're essential because without them, really the electric grid doesn't function. And so, these are found everywhere, and they are critical for the distribution element, the side of the grid. But also, large power transformers are kind of a co-equal part of this. They, in a sense, allow from power generation sources of solar, nuclear, wind. They power up generation, or they power up electricity so that it could be transmitted across the transmission network to the distribution network. I think our focus today and a lot of the conversation that's been happening in policy world and also in the manufacturing space, in the market as a whole, really kind of focus on the distribution side of the distribution transformers, kind of the distribution side of this equation. And so I think for our conversation today is where I want to focus, but also kind of say why we have these issues around supply and demand. You mentioned a few things in your introduction around, the things that are driving a lot of, electricity generation and electricity load in America right now. But from a market perspective, when manufacturers who NEMA represents are trying to build these items, it's like we have to look at where the market currently is, what are the things driving the demand, the supply that is currently allowed or currently being produced, and what could we do in the short, medium, and long term as a nation, as the market itself, to really kind of see where we can level out the supply and demand imbalance that currently exists.
Are we facing a supply shortage right now?
Yes, we are. And I put it this way, that so if you were to go to your local distribution transformer manufacturer now and say, I would like to buy a new transformer, it would take you roughly 2.5 to 3 years, depending on the specific type of distribution transformer you're looking for, in order for you to get that new order.
Oh my goodness, that's 2 to 3 years.
2 to 3 years. Whereas 5 years ago, that wait time for a new transformer was about 4 to 6 weeks. And so the capacity for manufacturing can't be scaled up or down, or it can't be scaled especially up as quickly because the demand for all of a sudden for all of these products has kind of hit almost in a perfect storm at the same time. The drivers, think about what we were talking about 5 years ago. We weren't talking about Bitcoin mining and AI and quantum computing and the explosion of data center build out. Of course, the IIJA and the IRA and the electrification, those bills hadn't been passed, which of course created a large focus demand for new EVs and electrification generally, and also the remanufacturing of America. And then also grid modernization, upgrading these old legacy products and systems that currently exist throughout the distribution grid in every corner of the United States, bringing those old systems that were built in the 70s and 80s up to the 2024, 2025, era. All of these things have happened in a very, very small amount of time, and the demand for these products has therefore catapulted exponentially. And so when we talk about, the supply chain really still exists to kind of meet the market where it was 5 years ago. And with all of these new demands coming on very quickly, it hasn't, and the demands are so great, that curve is very imbalanced. And so now manufacturers are trying to find the best ways to move forward to meet the demand, given they also have supply chain limitations on their end. So, utilities need more, data center manufacturers need more, end users need more, but then the supply chain vendors, which, manufacturers, they also now need more to turn around and look at their own supply chain and say, we need more copper, we need more steel, we need more aluminum. We need all these things to then scale up to meet those utility and end user demands.
Interesting. It sounds like the power system would function fine without any change in transformers. It's just that you couldn't put any new generation or very little new generation onto the system at the one end, and you couldn't take any of the power down at the other end to bring into the homes. So the electricity that you could put on the grid would just be running around in circles. But NEMA has suggested a virtual transformer reserve is to address future shortages and current shortages. But since it would take some time, I presume, especially future shortages, what is a virtual transformer reserve, and why is that a solution?
So the idea for a virtual transformer reserve is not the same as, let's say, a physical reserve most people might think about. And this idea or recommendation for a virtual reserve came out of the National Infrastructure Advisory Council report, which was a government-led effort which brought together utilities, vendors, manufacturers, to kind of identify what the challenges are around the distribution transformer shortage. So the shortage has become so great that it's caught the attention of Congress, the White House, and really kind of did an all hands on deck effort to say, what are the issues that have created this huge backlog, and what does it need to take in order to start to shrink down those long lead times to a more manageable and reasonable time frame. And so that NIAC report came out with 7 ideas, and one of those recommendations was for a virtual reserve. Now, a virtual reserve is really it's a fancier way of kind of saying it's a commitment guarantee, an order commitment guarantee, which is an attempt to try to create medium and long-term market certainty for manufacturers so that they have the confidence to invest capital in many ways, shapes, and forms into their processes in order to then scale up to meet the demand that currently exists. Meeting that demand there's no one particular way on which to scale up. It's a combination of collection of materials, minerals, it's the labor that goes into making these transformers. It's the capacity itself and the locations to build these transformers. And it's also the testing element, like where are these things being tested? So there's multiple factors and pieces around building up, the capacity in order to build more transformers. But one thing that I know the industry has been wary of in the past is that you've had these kind of peaks and valleys of demand that have existed over time. And so there have been, and the most memorable one for the industry was the housing crisis of 2008, where there was unprecedented demand then for all things for home building in general. So of course, distribution transformers to feed into that home building bonanza, but then all of a sudden, just as quickly as it was there, it was gone. And so it cratered and it left a lot of stranded assets that weren't able to be fully utilized. And again, not just physical assets, labor assets, especially where people just weren't going into the market to build these things. And so that has kind of created these issues, these market-based issues around production. And so a virtual transformer reserve would be, it's not about the government or someone physically holding on to spare capacity, because with a 3.5 or a 2.5, 3 year delay in getting new transformers now, there is no surplus that's available to then kind of stockpile and wait for a rainy day. That doesn't exist. But what a virtual transformer would do is that should demand at some point start to waver or slow down, to prevent manufacturers from being spooked or being disincentivized to continue investment, a back order or a kind of a commitment purchase, which is backed by a government, DOE, in particular, let's just say, it would provide that long-term, medium to long-term certainty so that the production doesn't slow down enough to where, therefore, it creates, in a sense, the opposite problem where there's not enough capacity to build, not because there is not enough demand. So that's the idea of it. I know other countries kind of do similar things with more commodities rather than transformers. I know Canada does something, and I believe Germany does something as well, where they, in a sense, become a backstop. So this isn't an unprecedented idea. It's just called something a little bit different.
You're touching on what I'd like to get into in a little bit more detail, which is, but before I ask the question, I want to reinforce what you said. This is not just a NEMA idea. This is an idea that has come from the entire industry and from federal oversight sources that want to find ways to stabilize the power sector. And so how would a virtual transformer reserve be created and funded? Who would run it? Who would pay for it's sort of like virtual because seems like there's this manufacturers would have some funding for keeping in place the capacity to build transformers when they are needed. But that's a lot of investment, and it would require some sort of oversight. How would it work? A little more detail, Peter.
So that's an interesting question because since it doesn't exist currently, a lot of this is a little bit of speculation. But for this to really happen, Congress would need to authorize this. And right now, DOE doesn't have the authority to do something like this, much less the money to then therefore go out and buy it. But then at the same time, right now, the market for distribution transformers, because it's not a commodity, creates this really kind of interesting dynamic about, well, how much money would need to be set aside, how would the processes go, and who would the money actually flow through? And so a lot of those questions are still kind of outstanding or kind of still kind of more theoretical, because manufacturers, of course, are making a product for what their customers want. And I think with regards to this product, it's important to understand that the diversity of this product is so vast that it's really kind of hard to say, well, what does a reserve, even physical or virtual, really look like? Because you really have, and right now there's roughly 80,000 to 100,000 or more varieties of distribution
Yeah,
transformers.
yeah,
And so,
that's exactly my next question. You anticipated it. Um, so as we're talking about how to create and fund, also, I guess in the time that we have left, getting into the idea that design standardization would help alleviate supply shortages and help create a virtual source. But how do you make this more standard? I mean, that there again. So I realize there aren't any real good answers to all these things, but let's talk about that. Add that to your what you're going to do when you explain to us how to create and fund a virtual supply.
yeah, so the reason why these products aren't standardized is because the distribution grid is 100 plus years old, and that matured in very different ways with very different resources and under very different means across America throughout, like I said, the past 100 years or so. And so every product that's ordered and every transformer is going to meet, in a sense, the moment that particular part of the grid that it's being deployed on is where it's at. And so, whereas if you look at more, let's say, modern countries or whatnot, that their grids might only be 20 years old. Well, they're all built to a relatively, to a newer standard. All of their equipment's more modern, and so everything can kind of go uh, be more used in tandem. But because the U.S. grid is so diverse and it's and in a sense so old or in very different stages of maturity, it's hard to standardize that. And so because of the lack of standardization, because of the diversity of end uses, this is where I mentioned labor in one of my earlier points. It's like these products still have to be handmade because there's no real way to automate the real driving elements of a transformer production, which is core and winding production. There have been efforts, industries working with DOE and whatnot, to try to see if there are ways to, on the periphery, see if there are better ways to assemble certain elements of transformers, whether it's, do you prefabricate some pieces in the production line? And in some ways, there's been these kind of outcomes where it's like, oh, well, if these things happen, we may be able to reduce the variations by 10,000 or, 20 or 30%, which are great. But in some ways, when you have 100,000 different varieties, 10,000 really doesn't really move the needle much. And so
Mm.
when we talk about standardization, those are elements that, of course, we want to move forward to, but also, how is it that we can, really grid modernization, the closer standardization as a whole is going to be difficult when you have so many variations to and end use applications for these products. And so uh, grid modernization efforts, I think, are probably the best way to do it, to kind of increase those gaps, but also bringing more and more people in to the industry, the labor and the workforce that can understand and build these things faster. That's, I think, probably the best short-term solution to kind of not just draw down those long lead times, but also identify ways to kind of make these products be produced faster. But when it goes to the virtual transformer reserve, it's really how do you help the end user utilities identify the products that need to be, in a sense, purchased. And that, of course, is going to be difficult too. So only because a utility out in Southern California is going to have very different operational needs than a utility that operates in Bangor, Maine. And
Yeah.
so it's going to take, so really a virtual reserve is it's really a federal program that really would have to integrate and really become a partnership with the local utility, municipal, state government. There would be a lot of cohesion that would need to happen and collaboration that would need to happen to make a reserve like that happen. But just given the long-term demand being so long, being 3 or so years, as I mentioned at the start,
Mm-hmm.
These ideas likely probably aren't, like I said, the NIAC report had 7 recommendations. This was just one of them. But it is something that, should be considered or thought about, because these long-term demands, 10 years from now, we might be having a different conversation. So it's good to keep these recommendations holistically looked at, and see, if we can't necessarily do a virtual transformer reserve now, what are other recommendations that could be achieved now that in some ways might help get to that virtual transformer reserve down the road?
Okay, I think that's a good place to leave it. I remind podcast listeners all the time that we are engaged in an energy transition, not an energy left turn. And this is just another example of how the long-term process is going to lead us to something brand new, modern, and better, but we'll have to work through it as we go. I want to thank my guest, Peter Ferrell, Director of Government Relations with the National Electrical Manufacturers Association, for describing the increasingly urgent need to deal with the electric transformer supply chain to protect reliability and resilience as new resources, spiking electricity demand, and extreme weather events add stress to the power sector. As always, I also want to thank our listeners for taking the time to check out the USEA Power Sector Podcast, now available on Spotify, Apple Podcasts, YouTube, and other social media outlets. Don't forget to subscribe, like, and share with everybody you know our quest for energy transition solutions.